Coming up on This Week in Radio Tech, Ben Barber is with us. Who's Ben? You've probably seen him at NAB shows. He's the CEO over at Inovonics. They make some really cool broadcast equipment, and they've been making it a lot longer than I thought. Let's check it out with Ben Barber, the CEO of Inovonics, coming up next on TWiRT. This Week in Radio Tech is brought to you by Broadcasters General Store with outstanding service, savings, and support online at bgs.cc. By Broadcast Bionics with the Bionics Studio, including talk show control, social media, and visual radio. Broadcast Bionics brings exceptional audience engagement to radio and TV. By Angry Audio. Audio problems disappear when you get angry at angryaudio.com. And by Max Connect Wireless, prioritized high-speed internet service designed for transmitter sites and remote broadcasts. Hey, welcome into This Week in Radio Tech, the show where we talk about everything from the microphone to that light bulb there from the top of the tower. It really is from the top of the tower. I'm Kirk Harnack, and you're so glad that you're with us. We're going to have a great show today, learn about technology, and learn about how some of this technology gets developed. What's the inspiration for the tech that we use? And there is some cool new tech out there that we need to talk about. Our guest, let's go ahead and bring our guest in. Without further ado, Ben Barber is here from Inovonics. Ben, hi. Good to see you.
Good to see you too, Kurt.
So Ben, I want to, we got to roll into a quick ad here in just a minute, but I got to tell you, I have been someone who appreciates Inovonics since about 1981. Does that sound right? Am my history right?
Yeah, no, that could be. Yeah.
Yeah. Back in 1981, I managed a little radio station, what the heck was it? In Berea, Kentucky. I'll think of the call letters, and I can't think of it. In Berea, Kentucky, and it was an AM daytimer, 250 watts, woohoo! And I wanted the thing to sound good, and so we bought a MAP 2 AM audio processor, multi-band, and man, that we made that Gates BC 250 watt GY transmitter. We made that thing hum, and it was good. You remember that processor?
I do. It was a little bit before my time with Inovonics. Going back, Inovonics started in 1972.
Okay.
Jim Wood and a business partner, they were both working for a company, and the tech company was on the downhill slide, and they looked at each other, and they both had a love of audio, and they went, "Hey, let's start our own company." And so they did. And obviously in 1972, we were still doing a lot with reel-to-reel tape decks. And Inovonics came out with a solid state replacement for the Ampex 350s and the Scullys and those sorts of things. And so that's where it all started. Now it's quite interesting. Everybody wants to go back and actually grab the tube electronics and see if they can get those things working again. But that's where we got our start. And then as, in the studio, radio was just kind of a natural progression, and we came out with audio processing. Our first processors were definitely not multi-band. They were just a single band processor. There you go, the 220 right there.
Yeah.
You see that picture, and that was the early days of processing. And then the 201, which is on the screen right now, I think the last run of those we built was probably in 1990. And we sold them in LA, and they instantly went off the shelf, and now you can find them on eBay for more than we were selling them for in 1990. So it's that's kind of fun.
Wow! And then we're going to look at more history in just a couple of minutes. This is really exciting. I didn't realize the company had been around that long. Jim Wood has been around he started a long time ago.
He did, yeah, in 72, and we're in 2021. And so 49 years. Next April will be 50 years for Inovonics.
Wow. Hey, We're talking to Ben Barber. Ben, what's your position there at Inovonics?
The president and CEO.
But you have a technical background too, don't you?
Yes. Yeah, absolutely. I started out, actually, I didn't send you a bio, but I should have sent you a bio. But I started out at 10 years old. My parents bought me a 65-in-1 kit from Radio Shack.
Oh, yeah.
And that launched my electronics career, if you could call it that. And always liked building, always liked just tinkering and building things and building transmitters, building audio mixers and that sort of thing. And then got into radio in 1986. and was doing on the air, but also doing engineering at the same time, and for a little tiny station in Alaska. And I enjoyed at the end of the 2 years, I enjoyed doing the engineering more than I enjoyed being on air. And that was just the way it was. So I started at Inovonics in 1988 as a bench tech and doing checkout and final assembly and checkout for our products. And at that time, we were quite a bit smaller, fewer people, and that was a full-time position. And that's where I started in '88 with Inovonics.
I'm excited as we move through the show to hear about the inspiration for some of the products. And what I didn't really realize until I started doing ads for one of your products here on the show is the beautiful web development you guys have done, the remote control and the information you can find out remotely. So we're going to get to that in just a few minutes. We're talking to Ben Barber. He is the CEO over at Inovonics, and also has an electronics radio background. So that's pretty exciting. It's always good to have manufacturers with actual radio people working there. I'm Kirk Harnack. It's This Week in Radio Tech. I'm, by the way, in the Telos Alliance studio in Nashville, Tennessee. Glad to be back in the studio after being out for a couple of weeks. And hey, our show is brought to you in part by our friends at Nautel, and I really want to point out something here about Nautel. That's the Transmission Talk Tuesday. These discussions, they're really a roundtable discussion. It's not really a webinar. You can join Nautel for Transmission Talk Tuesday's roundtables discussion. The next one coming up is September 21st. It's SDR, Software Defined Radio Technology. And, I've dabbled with this a bit, but when you have somebody to kind of hold your hand, to be your Elmer, to put it into ham radio terms, there's so much you can do with software defined radios. Well, Alex Hartman is an expert at these, and he's going to be the guest on September 21st. You want to go register for this at nautel.com/webinars. Nautel.com/webinars. On September 28th, the topic is lean for broadcasters. Lean manufacturing, how to identify and apply a value stream associated with your broadcast industry workday processes. Okay, that sounds interesting. Guest Brian Irwin is there. He's the Nautel head of operations, and he's going to explain some of the things that they do to be lean at Nautel, and also apply some of this to what you do every day, what we do every day as broadcast engineers. And so, wow. In October, a couple of things coming up to be announced for October 19th, and the 50th Transmission Talk Tuesday Gala with prizes. So you want to be sure you register for those. You can go to the Nautel website to register. It's really an easy process. It's real quick. Fill out a few fields. They'll send you an email a day before, and then they'll send you another email an hour before the Transmission Talk Tuesday Roundtable starts. Check it out. I've enjoyed every single one of them that I've attended, and I'm really pleased that Jeff Welton actually asked me to be part of one of those. So anyway, check that out, nautel.com/webinars, and sign up for Transmission Talk Tuesday. Thanks a lot, Nautel, for sponsoring This Week in Radio Tech. All right, we're back with our guest, Ben Barber, CEO at Inovonics. So Ben, so let's see, I bought that MAP2 processor before you worked for the company. And boy, what a cool product that was. So when you started working there, I guess what I'd like to get in, what was the atmosphere like when you started working there? What did you feel like you were part of a moving up, growing, cool company, or what was your feeling when you got started there?
It was interesting. I had not worked in manufacturing before starting at Inovonics, so that was all kind of new, and the whole idea of production and everything was very new because I was more of a DIYer, though that term wasn't around back in 1988, I don't think. Just designing and building one-off pieces for myself or for the radio station that I worked at. So the whole idea of building runs and actually manufacturing multiple products was something very new to me, which was great. And Jim was very patient and showed me how to do that, and really took me in and showed me how to run a company and how to make it work, rather than thinking like a DIYer and a hobbyist. So that was good for me, and that was. Yeah, back in '88. Also, if you remember, in '89 was the whole NRSC movement for the AM, and we had just come out with a AM low pass processor, so you could meet the 10 kilohertz mask and do the peak limiting and everything, which was all part of the AM. Let's keep it going and make it sound better movement. So a lot of people like yourself had the MAP processors, the MAP 1, the MAP 2, or the DAPs, or just any number of audio processors that didn't have the 10 kilohertz filter in it. So that was kind of my launch into, hey, this is what we're doing. And we started selling a lot of those. And that was my launch into understanding what audio processing was for radio.
You mentioned this this processor. This is still on your history page. This is not a product page, but this NRSC winner. And you know what? I installed a bunch of these, and sometimes barefoot as the only processor on there. It wasn't the loudest thing on the dial, but it was clean and it complied, and that was what we were interested in. And then sometimes it was after an existing processor in the chain.
That was the whole idea of the 222 anyway, was it was to go after whatever you currently had. It didn't have an AGC in it, so it just had a peak limiter, a high frequency limiter, and then the low pass filter. So that was what it was. It was a bolt on at the end of your air chain type of processor, and that way, you didn't have to go out and buy something completely brand new, and it was there. It worked, and it worked well. So. Yeah,
that's very cool. And something that I've noticed about your processors often employ a technique that is PWM or PDM. Tell me about that technology.
Yeah, pulse width modulation is what it is. And if you think of turning on and off an incandescent light bulb anyway, maybe not an LED light bulb, if you sit there and you turn it on and off at a 50% duty cycle, in theory, your light should be 50% dimmer. It should be halfway. So what you do is you just turn the audio on and off at a very high frequency, and you're actually chopping it on and off. But and you can't hear that, but it controls the level of audio. So if you are doing it at 50%, then you're at 6 dB loss. If you do it at 25% off and 75% on, then you're up around 3 or 4 dB of loss only, and vice versa. So you can get quite a bit of dynamic range of control by doing that, and you don't have the distortion artifacts and things like that you do with FETs and bipolar transistors. So that was something that Jim had come up with after the MAP2 processor. Obviously, your processor was all controlled with FETs and bipolar transistors, but later on, we came out with a PWM and patented it for doing audio level control, and it worked quite well, and it was quite transparent. That was the advantage of doing it that way.
So can you, I'm not sure how deep you are into that technology. When you are controlling a level with PWM, are you actually chopping the audio at an extremely high rate to get less and more of it coming through? Is it actually the gain control device?
Yeah, that's it. Yeah, you're turning the audio on and off at a frequency usually up over 100 kilohertz. So obviously you can't hear it, and it's very easy to filter that out then, because it's so far beyond 10 kilohertz in the AM band, or 15 kilohertz in FM, that you can filter the switching frequencies out really easily.
Sure.
So yeah, you don't have to have too sharp of filters, and it works quite well.
And there are certainly AM transmitters that work on this theory as well. PWM AM transmitters, typically the ones I've dealt with, I think worked about 70 kilohertz. And again, easy to filter out. And now you've got exactly the waveform, the signal that you want. So I didn't realize that a PWM audio processor was working that way as well. Okay.
Yes. Yeah. And most of our processors from, I'd say, the 222 on were all done PWM until we got into DSP. But yeah, it was even the multiband processors. You just multiband frequency split and then do the PWMing of each band and then combining, and it works really well.
You mentioned transparency. Does doing gain control that way, other than having to filter the switching frequency, does it bring any other problems that have to be mitigated?
No, very low distortion. There's, yeah, you don't have that problem that you used to have with FETs and balancing modulators and things like that. So with switching at very high frequencies, you got away from the whole THD problem.
Ah.
So yeah, distorting your waveform. Though every audio processor distorts the waveform in some manner. So, yeah, exactly. That is the point. Yeah, but you don't want to doing things that are unnatural and that sound terrible.
It's interesting. Yeah, I explain audio process to people who aren't in the business, laymen, if you will, and we distort the audio, but we distort it in the way we want to, and in a way that is not unpleasant, typically, to your ears. We just try to make it louder, typically, not always. That's not always the goal, but louder, sweeter. Bring up things that you were missing before. Clean up things if we can.
Yeah, when somebody asks you that you meet at dinner or at a party or a barbecue or something like that, oh, what do you do? And you try to explain to them, we make audio processing, and they go, what does that mean? The way I describe it is I say, if you've ever listened to classical music, it gets real quiet. And what do? You reach over and you turn up the volume. And then pretty soon it gets really loud. The whole orchestra comes in and you turn down the volume.
Yeah.
So what we do is we sit there and do that automatically and give you a more consistent level. And everybody goes, oh, okay, yeah, that makes sense. And then if they ask more questions, or if they're musically inclined, then they start asking, well, what happens if the cymbal crashes? Does all the do you turn all the gains down? Well, no, then there's multiband processing. But that's my simple explanation. That is just it's just a machine turning the volume knob up and down so that levels are more consistent. That's it.
That's, my own explanation I came up with years ago was there's a little man with a volume control, right? And it first goes to the first guy, and he's kind of slow and old, and he kind of adjusts it up and down, and maybe he's a little bit late in doing so. And then we split the audio up into, low, medium, high, and there's a guy on each one of these, and they got volume controls. And then there's a guy who's like, he is whacked out on crack at the very end, and he's got a really super fast volume control.
Right. Yeah.
But when I explain in Inovonics PWM, I'm going to have to say there's a guy with a switch, and he's moving it up and down 100,000 times a second. And does he leave it on a little bit more or off a little bit more? That's the volume control.
That's it. Yeah.
Oh,
yeah. And they're going to look at you and go, I have no clue what you're talking about.
Hey, Ben, we're going to hear from one of our sponsors, and I'll go ahead and ask you about any interaction. Typically processing for streaming audio, streaming video, processing for television, maybe for cable channels, is different than processing typically for AM or FM transmission. And one of the things that's become popular is putting cameras in a studio. And our sponsor is Camera One from Broadcast Bionics. So what I want to ask you is, do you guys make processors that are appropriate for streaming audio and or for television broadcast?
We do. We make a couple of stereo processors that obviously don't have composite output in them for that reason. And basically, it's still very similar to an FM processor, but it's backed off. What you do is you back off the peak limiting and that sort of thing. So you don't get clipping and artifacts like that. And then keep everything below 0 dBFS and pretty good place to be.
And for modern television, there's no pre-emphasis. Just for FM there is, for AM Correct. there is, but yeah, cool.
Correct.
Hey,
yeah. I'll just check boxes on the web interface.
We are talking with Ben Barber. Ben is the CEO of Inovonics. By the way, I thought of those call letters from Berea, Kentucky. It's WKXO. How did I forget that? WKXO in Berea, Kentucky. We had a MAP 2 processor back in I think I probably bought that in 82. Wow. Hey, what memories. Hey, we're going to be right back. Camera One is our sponsor, and we'll be back with Ben Barber in just a second.
Camera One from Broadcast Bionics. Designed to bring video to your audio content. Visualizing radio and podcasts for social media. Camera One can automatically create, capture and brand professionally switched video for live streaming or upload, making your production shareable. Control and configure using a web browser on any device. Camera One is available as a 4-camera or 8-camera system using the Blackmagic A10 Mini range, including the A10 Mini Extreme. You can use cameras to suit your studio and your budget. You'll need one camera for a studio wide shot and usually one camera per microphone. A standard multi-channel sound card or IP driver monitors audio from each studio microphone, and we work natively with Axia systems. Ideally, this will be a post-fader feed from each mic, although you can use pre-fade audio or a mic split if that's all you have available. These audio levels are used to intelligently switch the video feed when each contributor is talking. You can also group microphones together into one shot and use the audio from a mixer's aux bus. You can use Camera One's auto switch feature, or disable it and switch using the on-screen buttons or the buttons on the A10. Recordings can automatically start when you tell the system you're on the air. This on-air indication can be linked to your studio's red lights via IP or an Avantec Adam GPIO interface. You can quickly browse all the videos that have been automatically created during your broadcast, download them and post. Camera One is a user-installable system. You'll need a good spec Windows 10 PC, i7 with plenty of storage and 16 gig of RAM. It's better if this machine isn't used for anything else. Remember, you can control the software in a web browser on another device on your network. Camera One, a thrifty way of creating scroll-stopping video from your show or podcast from Broadcast Bionics.
One or any other products from Broadcast Bionics, they make products to help you get your social media content in order on the air fast and looking really good. So check out Camera One or anything else from Broadcast Bionics. You can go to bionic.radio to find them or Google them, Broadcast Bionics. But bionic.radio is the website. They make amazing, amazing stuff. All right, I'm Kirk Harnack in the Telos Alliance studio in Nashville, Tennessee. Ben Barber, the CEO of Inovonics, is our guest, and we're talking a little bit about history of Inovonics, and we're going to get into some of the newer tech. But Ben, would you mind if I look a little bit more at some history? Would that be all right? Sure.
Yeah, you bet.
Okay, so from your website, there was the David. I remember the David line of processors coming out. What was the impetus behind this processor?
Well, back in 1992, you remember there was the Goliath of audio processors, quite the big name, and a lot of stations.
I get it now. I never got that.
Ah, okay.
So I think we're talking about Orban in '92 was the.
Yes. Yeah.
Okay. The Goliath process. Okay. Gotcha.
Yes, definitely. Gotcha. And every station wanted one, but not every station could afford one. So we decided to come out with a 1U box, very simple. It had one knob on the front. It was just more or less. And that was it for audio processing. And the 715, the original audio processor, was a split band processor. So it was a single band, wide band, and then a independent high frequency limiter or high frequency processor.
Yeah.
But it had AGC compression limiting, little bit of composite clipping in there, and gave you composite out. So you run left and right out of your board, and there it was, all in one box. And it was truly the David versus the Goliath. And I'm not sure that in this case David won, but it definitely made a dent in Goliath, and we sold a lot of them. And I'll be at shows, and people will still come up and I bought one of those little Davids. They always call it a little David, and boy, that just made us sound so good, and we just loved the sound of that thing. And that was it. That was David versus Goliath.
Wow. That's really awesome. What a great story. And yeah, I've been to so many LPFMs, community stations, obviously low budget operations that had these.
Right.
And maybe some still do, but people, a lot of times people would put a station together who weren't radio people, and they didn't know they needed an audio processor. So this wasn't even on budget. So they got to go get the money to get this thing.
Right. Yeah.
Cool.
It's interesting. You're calling this show innovations at Inovonics, and Inovonics. The original name was going to be Novonics, and when Jim and his business partner went down to register it as a California corporation in '72, they wanted the name Novonics, and it was taken. So they thought, well, gosh, we're sitting here. What do we call it? Let's just put an I in front of it and call it Inovonics. But it's spelled with one N, and so it's not meant to make us sound innovative. though people think that's what it is. But over the years, and looking at that history page is a lot of fun, because you see us starting off with tape recorder electronics, which obviously is not around today, and then audio processing for high-speed duplication and that sort of thing, with, again, reel-to-reel tape electronics. And then we moved into AM and then FM and then mod monitors and so forth, and we can get to that. And even though innovation wasn't part of the name of Inovonics, it's funny. In the office, we have a saying that says "innovate or die," because I'm sure you're very aware too in the industry that there's a number of manufacturers who just ceased to innovate. And when you cease to innovate, your company becomes irrelevant, and you ride the tide right to the bottom, and right out of business. And so in the office, we say innovate or die, but that doesn't sound like a very good marketing slogan. So to the outside world, here I'm revealing what we talk about in the office, but to the outside world, we say always innovating, and we put a big smile on our face. Mm-hmm. So that's the way we look at business, is that you've constantly got to be changing and keeping up with the industry, or you're going to become irrelevant and go by the wayside and out of business. And so, we've been doing this for 50 years, and we're still in business, we're still innovating, and we still have a smile on our face.
Now we're going to get to the current, some of the current innovations in products, and I'm just really excited to see something after in the next part of the show. But I still want to look at some of the history, because your history is important. For me, Inovonics would come out with a new product, and I would always say, I want that, and it's just about affordable. So the next thing I would be curious to think about is modulation monitoring. And prior to you guys coming out with a modulation monitor, I never bought a new modulation monitor from the companies that had them, with the ones with big meters on them, because they were so expensive, and we already had one, so we just kept it running. So what made you guys decide we need to come out? We'll sell some mod monitors if we come out with one.
It's very interesting. We came out with a product that we called the Sentinel, and it was the 550 was the model number of it. And it was a 3U unit, and it had tons of LED meters on the front of it. And it was an AM FM monitor, and it had FMX in it. So it goes back to those days. Yeah. And it had all sorts of LED diagnostics on the front panel, and everything was done discrete. You take the top cover off, and it was an amazing box inside. Now it could all be done with one microprocessor.
It's full of parts, you're saying.
Oh, it's full of a lot of parts. Okay. But we came out with this product, and it was pretty expensive at the time, and we took it to a couple of NAB shows, and there was a guy from Brazil who came up to us, one of our dealers at the time, and he said, all this stuff is great. It would show dynamic range. It had a CBS loudness meter in it, a discrete, I think there was 10, 12 filters in there, maybe 16 filters, all at different levels and everything, to follow the CBS loudness curve. But he looked at that thing and he said, this box is overkill. If you could just take this one meter, which was the FM modulation meter, and put that in a box, you'd sell thousands of them. And we that's right. We just introduced this product, and we think it's really cool. And, a lot of people are wowed at it because it's got a lot of eye candy and everything. But we took his advice, and we took that one meter and that circuitry and put it into the 530 and introduced it as a modulation monitor. And we sold thousands and thousands of those. So it was a very successful product. And that launched our modulation monitor part of Inovonics.
I think part of the success there had to be for these new groups that were coming up with a number of particularly smaller stations. Typically, my radio stations, I'm part owner of 18 radio stations. I think we probably own 2 or 3 of the 530s or whatever the successor, whatever's current, right?
531 came after the 530. The 530 was actually analog analog tuning, and you held the button down, and then you inserted a little greeny screwdriver in there,
Yeah.
and you had the wonder bar of the frequency going across the top scale, and so you tuned it into analog. It had an AFC in there, if you remember what those are, to keep you in the middle, locked in the middle. But it worked well, and it was affordable, and it didn't have a lot of can tuning or anything like that. The IF stage was all done with discrete components, but it was done with filters and that sort of thing, with op amps and stuff. So you didn't get the drift and heat changes and that sort of thing that you got with a more traditional modulation monitor, where you didn't know if the calibration was still accurate or not. I mean, we still get 530s back occasionally, though they're pretty tough to fix because parts just aren't available for them anymore. But people send it in and say, please calibrate it. It still works. And it's like, okay, yeah, we'll check the calibration. And it's usually pretty good. You get some dried out caps in there, but that's about it.
But these made sharing among stations easy.
Yes. Yeah. And it was innovative too, because you could actually pick up off air. At that time, most modulation monitors had to be connected directly to the output tap of a transmitter.
Right.
And you didn't have the ability to put the modulation monitor at the studio, which, hopefully wasn't very far away. And you would use a good outdoor antenna, directional antenna, and your modulation was, pretty good. You could see what you were doing. But that, and then the ability to actually put presets on there where you could tune around and watch your neighbor and everything, that was kind of innovative.
That was a benefit. Yeah. I always had to warn program directors, hey, listening off the air, almost everything that can go wrong with listening over the air or measuring modulation over the air is going to make it read higher than it really is.
Right.
If you want to set it and be sure we're as loud as we can be, we need to take this out to the transmitter side and hook it to a tap to the transmitter.
Yes.
And that'll give the lowest reading possible, and it'll be accurate. Yeah.
Right. Yeah. We also, on this, we put a multipath light on it, which was something new too. And again, because picking it up off the air, because if you've got multipath, you're adding or subtracting to the total modulation levels, and that would give you erroneous indications.
Can you give me any idea how you guys sense the fact that there's more multipath than you might want?
Yes, it was clever idea. In theory, your 19 kilohertz pilot should be rock solid. There you are, 9% or whatever you were going to be. I mean, it should just be absolutely rock solid. So what we would do is we would filter for the 19K, and then we would AC couple off that, go into a gain stage, and look at any modulation of the pilot. And if you were getting modulation of the pilot, which should be rock solid, then that's what we called multipath.
Now, it could have been transmitter-induced multipath or transmission system-induced multipath, but if you were able to move an antenna around outside and reduce it, then you kind of knew it was reception multipath.
Yes. And also, if you were doing composite clipping, you would splatter up there in the 19 kilohertz range. But it wasn't so much. I mean, so if the multipath, you saw a little bit, whatever, you're probably fine. That was the thing, and having a meter at the studio. I mean, you wouldn't want to do an FCC proof at the studio if your transmitter site was very far away, but it gave you a meter to look at and something to say, we're in the ballpark.
So, so many people have enjoyed the mod monitors. What about RDS? You guys got into RDS. You saw an opportunity here to help stations out. Talk to me about that philosophy.
We did. We were working with a company in the UK at the time, and they had an RDS encoder, and it was back in '95. I mean, in the US, it was just hardly no one had RDS radios or anything like that, and not very many people were doing that. So we thought, hey, this is a opportunity to be, on the edge of something, and so we introduced the 610, which was, oh man, it was a terrible. No, it wasn't a terrible product. It was a pain in the butt to program because it actually was an EEPROM, and you had to physically remove the EEPROM and program it with a PC software that was running in DOS, and it programmed through the parallel port of your computer, which was innovative. I mean, it was a great idea because you had an 8-bit parallel port, and you were using an 8-bit EEPROM. So why not just program every cell in the EEPROM, and that would work. And so that's how it did it. But it was very cumbersome to use. Maybe that's a better word than pain in the butt.
Yeah.
But that was it. And we introduced it. You could put 16 different messages in there. You could have it rotate through the messages, or you could select a particular message. You could even ground a contact pin on the back and play your alert message if you wanted to. So that's how we got into RDS. Now we're the only U.S. manufacturer of RDS equipment. So we've kept our legacy from 95 till currently now, and still making RDS gear. So right after we came out with the 610, though, it was expensive for smaller stations that wanted to have an RDS presence, but didn't have the money to buy it. So we came out with just a very simple box, and that was a 701. I don't think it's listed on here in our history, but that was innovative. And you programmed it through the parallel port, and it just put out the same message all day long. But it gave you your call letters, Live 105, place your favorite hits, something like that. So that was a good thing for stations.
Yes. Ben, you remind me of back in the day when I tried to get one of my client stations to install an RDS encoder. And the GM asked, well, how much does it cost? I said, well, $1,000, a little bit more than that. Well, who can pick it up? I said, well, right now, not many cars can pick it up, but more newer cars have. He said, $1,000, I'm not interested. Until, of course, he bought a new car.
Yes.
And he noticed that, like the public radio station, which had some kind of initiative to get RDS out back in these days, whenever that was. I want to say it was the late 80s, but I could be wrong. And then he had to have it. What? Get that thing in here yesterday.
Yes, it was huge on station owners and managers' envy.
Yeah,
that RDS gained its success. So just exactly what you're talking about. Yeah.
Let's hit on the FM relay receiver real quickly, and then we're going to look into our next part of the show and talk about current technology. What was the idea here?
The idea was that we came out with a 630 because there were a number of units out, a number of receivers for translators, and that was about the time when translators were really starting to just mushroom. And originally you had TEPCO translators and so forth that would actually receive a section of the RF spectrum and then heterodyne it and rebroadcast it on another frequency. And those worked, but they were problematic. You were rebroadcasting a lot of noise and everything else. So we came out with the 630 was our original one, and it was a PLL frequency locked product. It gave you nice composite output. It was pretty clean. Wasn't real sensitive or selective, but it did the job. And if you had a good antenna on the front end and maybe some cavities or bandpass filters, it did the job. And it was locked on frequency. It didn't drift, which was a real plus. There were a number of receivers out there that did drift really badly, and ours didn't. So we sold a lot of those.
Wow. Very, very cool. Then you came out with this mini encoder.
That's it. That's a 701. That was, that was the one. Wow. $390. My goodness. Back in the day. So your station manager could get on the air for, $390 with RDS. And that product was really a fun little guy because it was, nobody made one like it. And so that was a very cool product.
Not much on the front panel to confirm operation, I suppose.
No. There was a power LED, there was a programming LED, and then there was a pilot lock LED because that one didn't even have an oscillator in it. So you had to lock to the 19K pilot, and then it multiplied it up by 3, and then an RDS data light that was absolutely looking at ones and zeros and just blinking as ones and zeros flew out through the EEPROM.
Gotcha.
That was it.
So actually, you can answer one question before we go to break, and that is, why is it important that RDS be synchronized to a 19 kilohertz pilot? And so many RDS units have a loop through in them that you can take a 19 kilohertz, perhaps a square wave, from your audio processor, your FM encoder, and send that out and sync it that way. Or you can take your FM, composite output, and run it through your RDS encoder itself, and it'll, of course, sync to the pilot that's there anyway. Why is that so important?
If you look at a modulation monitor and you don't lock the 57 to the 19K and you just play a steady state tone at 100% modulation, you'll see the modulation just drift up and down by whatever the modulation is of the RDS. So if you're doing 5% injection, your modulation is going to go up to 105 and then down to 95 and up to 105. If it's locked to the pilot, that doesn't happen. But as it drifts and just moves back and forth, that's what you get on your modulation monitor. So you would get an inaccurate reading if you weren't locked to your pilot. That's the short answer.
Okay. That makes sense. And I always sometimes I'll follow a non-engineer who has hooked up an RDS and there's no synchronization to the pilot, and I think we need to add a cable to this and fix this right here.
Right, and if you're in mono, it doesn't matter. It won't change your modulation. But if you have a pilot, you're supposed to be locked to it, and that's the reason for it.
Gotcha. Makes sense. All right. Hey, we're talking to Ben Barber. Ben is the CEO over at Inovonics. Inovonics Broadcast is the website, and we are going to look next at, we've looked at some history, and that's good to know, but the innovations that they've been doing with some of their modern gear, I think is just fantastic. We're going to look at some web interfaces for them, and the functions that are built into these pieces of gear are really helpful to broadcasters, broadcast engineers like you and me and so forth. Hey, our show This Week in Radio Tech is brought to you in part by my friends at Angry Audio. Angry Audio, makers of this headphone amp right here. It's called the Headphone Gizmo. You know why this is my favorite? So I always joke, because it's so smooth. You won't snag your pantyhose on this this headphone amp when it's attached underneath the bottom of your audio, your console, your tabletop, right? You can put it on underneath there, put the screws in. It's got little rubber feet right here, so it's nice and quiet. It doesn't sit there and rattle, in case it's not quite flat. It really sits up there nice and snug. And on the back, there's a power input, right here, for 16 volts AC. It's easy. And you can use that to inject power, but you can also daisy chain these using the Studio Hub standard. Uses ordinary Cat5 cable. You can daisy chain from one headphone amp to another to another. You can power 3 of these off of one 16 volt AC wall wart. And so that makes it really convenient for 3 positions around underneath the console. That's great. It's got both 3.5 millimeter and 1/4 inch headphone jacks, and it'll get nice and loud there for you. There's another thing that you can get. Oh, I don't have it right here. I put it somewhere else. Oh, well. The Studio Hub line of headphone amplifiers, those are available at angryaudio.com. And while you're at Angry Audio, be sure you pick up on these, because if you're wiring any new studio, especially if you're wiring a studio that has audio over IP, Axia, also WheatNet IP, they have on the back of their units, they've got the RJ45 connectors for audio in and out, whether it's analog, balanced analog audio, or AES digital. Now, these are gold-plated connectors. That's the standard anyway for RJ45 connectors, so they work really well for audio. Well, you're going to want to interface those easily without doing a bunch of soldering. Oh, keep the soldering iron in the toolbox and just use these. They work great to adapt Cat5 cable and RJ45 connectors to your professional audio gear. And of course, they come in male and female XLRs. They also come in 1/4 inch tip ring sleeve. They also come in RCA connectors. It will be unbalanced at that point, or just bare wire. So you can put whatever connector on there that you need to. So check that out from Angry Audio. You ought to check out the whole website at angryaudio.com, because you'll find a huge selection of things that you need that are going to make your studio builds better. And if you're rebuilding, or let's say you've just been putting up with a problem in a studio for the longest time, They have solutions at angryaudio.com that will really help you out. Trust me on this. Go to the website, angryaudio.com. And if you want to order some Studio Hub gear like this, call your favorite dealer and insist on actual Studio Hub brand. Studio Hub's been making this stuff from the very beginning. Angry Audio owns Studio Hub, and Angry Audio now is, Studio Hub now is Angry Audio. They still make the same adapters in the same factories with the same jigs and the same good people who know how to make it all and make it reliable. angryaudio.com. Thanks for sponsoring This Week in Radio Tech. Hey, our show is also brought to you by my friends over at Max Connect Wireless. Here's John Takach to tell you about it.
With all of the recent cybersecurity attacks against large corporations, we were looking for a product that would give us the ultimate security at our transmitter sites and as well as with our broadcast equipment. Max Connect fits the bill very well. Its greatest security feature is the fact that it gives you a single static IP address. Using this single static IP address allows us to close hundreds of open ports on our firewalls across the company and restrict access to only the Max Connect IPs. This has greatly reduced our exposure to the World Wide Web and made us much more secure moving forward. It's also given us the ability to expand as needed in a secure fashion.
And no matter which 4G LTE modem you might have, you can get these from Max Connect. It's really not about the modem. It's about the SIM card that's in it. It's Max Connect Wireless. You're actually using their network or their network arrangement with any of the major carriers. AT&T, Verizon, T-Mobile, Sprint. You can connect to them, whatever your favorite carrier is, or one that you know has coverage where you know you need to be or has the best coverage. You can arrange for that carrier to be your carrier. And so Max Connect Wireless has made arrangements for you to get prioritized data over your connection, no matter how much else is going on in the area. And that means you can do a live broadcast from a stadium full of people at halftime when everybody's posting Facebook pictures. You get prioritized data. Basically, it's your own channel that's set aside for you. The only people with a higher priority is first responders, and that's the way it should be. But you as a broadcaster get the second priority right after first responders and before all those yahoos in the stands. So check it out. And the fixed IP address is really helpful too, as John Takach noticed. MaxConnectWireless.com is the website. And it's spelled funny, I know. So there's a link in the show notes. All right, we are rolling through another episode of This Week in Radio Tech. Our guest is Ben Barber, CEO over at Inovonics. Ben, we've got about 15 minutes left in our show today. Let's jump into today's technology and what you really want to talk about. What are you making? What's hot? What are engineers interested in? How are you solving their problems?
Oh, a couple of years ago, a few years ago now, we came out with a product called a site streamer. And it was an innovative product. It's in our InnoMini form factor, which is a 1/3 rack size. So you can put 3 of them in a rack. And I've got a local friend here. His name is Brant, and he has a 10-watt translator down in a canyon. It's about 50 miles away from here. And he has absolutely no way of knowing if that station, if that translator is on the air or not. And so we thought, you know what, a small compact unit that would be able to remotely give you feedback what's happening at a translator site would be a great product. And so we did. We came out with what we called the site streamer. The FM version is a 635. We make an AM version and a HD version. And these little guys go at a remote translator site. They have a web interface, like you were talking about earlier, our web interfaces. And you can pull it up and monitor it on any web-enabled device, so your phone, your tablet, your computer. And it doesn't use an app. It doesn't use any special software. And you can see all the different parameters that are being received right then. So signal strength, audio levels, RDS data. You can see that. And then there's a little speaker button up in the right-hand corner, and you can press that button and stream your audio. It's delayed by 5 or 6 seconds, but you can actually hear what's happening at that remote site. And it can send you an email, a text message, and just let you know what's going on.
Is this the page that you've got brought up on your shared computer?
No, that's for a different product.
Gotcha.
But
okay, go ahead.
What really excited me about this product is when we brought it out, we thought, oh yeah, we'll sell them to a few people with translators around the country, or maybe people that have a couple of remote translators, or maybe some networks here and there, that just can't pick themselves up in their coverage area. I was in Singapore at a show there, and I'm standing in the booth, and walking down the aisle are these two guys coming towards me from Taiwan. I've never met them. They both whip out their cell phones, and they're so excited to show me on their cell phones how they can monitor their stations in Taiwan while they're in Singapore. They can listen to the audio. They're doing the product demo for me about how great this product is. And it changed the way I looked at Inovonics. We're in a small town in California, Northern California. We're south of the Bay Area, about an hour and a half south of San Francisco, right on the coast. And we're in a small town. We're a small company, and yet we're making products that are being used worldwide. And it just blew me away that I didn't realize the reach and scope that we have, and how many people are enjoying our gear and using it every day. And it put a smile on my face. I came back from that show in Singapore, and I just went, guys, we don't realize what we're doing and how we're helping broadcasters worldwide. So it changed the way I look at products. It changed the way I looked at product development, what we're doing, and why we're doing it. So
would you mind if I show the live demo of the site streamer?
You bet. Yeah.
Okay. So I brought this up on my computer. This is one thing that I really appreciate about what you guys have done on your website. You've made available the products that have a web interface, that have a meaningful demo. You've put them on your website, and this is live, right? This is not a playback recording.
No. This is a live station right here in the Santa Cruz area, 97.9. So you can look there. You can see the program service name. You can see the radio text. You can see your PI code underneath there as your signal strength, bandwidth, multipath, signal to noise. Everything is right there on the now playing screen. Then if you click on RDS info, we were talking about that earlier. You can see the RDS info. You can see what groups are being received, what data is coming through. And then right up there at the top, you can see the little speaker next to the 128. So if you click on that.
Yeah. I'm not sure what's going to happen with regard to audio.
Yeah, okay, well, I don't think your viewers can hear it, but
I heard it. I heard it, but yeah, it's not being fed into this recording, but I sure heard it.
You heard it, and that's the beauty of this thing, is that you can, inevitably, again, with Brant and this little 10-watt translator down in a canyon, it would be off the air for 3 days, or somebody would finally call the station and say, hey, you've been off the air, or there's a big buzz in one channel, in the right channel, or something like that. And he just had no way of knowing that station had a problem. And so now he can get a text message, an email from this box. He can listen to the audio in more or less real time, and he can gain a lot of information from what's going on at that remote site.
I noticed that there's you have several. You have a Sophia line of site streamers, and then the one we were looking at. What's the difference in these different lines?
The Sophias are what we call Site Streamer Plus. So it's a half rack package. It has a better display on the front panel than the little site streamers. The little site streamers, about all you can really read on those is the frequency, signal strength, and your IP address. And that's kind of it. On the Sophia Plus, you actually get real metering. You can see history here. The web interface is much more advanced. You can actually look at 24-hour time span. If you click on that,
my goodness,
click on that button, 24 hours, so you can see your modulation for the last 24 hours. You can see the signal strength, the RSSI. So 16 hours ago, the signal strength went down. That was probably when they went to nighttime power.
Sure. Yeah.
And then 4 hours ago would have been 6 a.m., something like that. So hey, their power went back up. So it gives you a lot more diagnostics. One of the things with the regular site streamers is you can only stream the audio to one person at a time, and it only has the horsepower for that. Our Site Streamer Plus line, you can stream audio up to 10 different people simultaneously. It also has a AOIP network connection on the back. You can do AES 67 audio out of it. So just a lot more features and functions, so a lot more advanced.
And then this is an HD site streamer.
Yes, yeah. This one again is the little tiny guy. But if you look at the listener experience button there, you can click on Show FM HD1, HD2, something like that, and okay, there we go. Okay, so you can actually, in one location, you can see what the FM is doing. So the FM RDS, you can also see the HD1, you can see the HD2. So it's a listener experience. And on the Sophia site streamers that again have more horsepower under them, you can see logos and the artist experience and everything else going there. So
really,
yeah.
Wow.
Click
so
on
I can go to the Sophia 568.
Yes.
That one? Okay. And we can go to, as soon as it pops up, we'll look at listener experience, right?
Yes. Wow.
Oh, this is so
and so there
and
you
sure
go.
enough, the artwork comes up.
Yeah, and you'll see a whole bunch of little dots underneath the artwork there for the HD1. If you click on one of those dots, you can actually get a history of the last 15 images. Okay, you just moused over that. So the gold bar or band around that means that that's what's being broadcast or viewed right now. But click on the little gold dots underneath the images over there.
I'm either blind or just not seeing the gold dot. There. Yes. Okay. Gotcha.
Yeah. Okay. So you can look back. So see, there was a image that was actually not triggered. Some other images that they were showing, and this just goes through, and you can see your history. Also, by mousing over the image, you can see the data for that image. So you can see the size, you can see when it was received, because the image has to be sent before the song starts, because there's a time delay there.
Yeah.
And then once the image is received by the receiver, then you click on trigger that image, and then it's viewed on the radio. So it gives you all sorts of data, like if the image is in the wrong format or the wrong size and that sort of thing. You can actually even click links in there and go to Ibiquity's website, and it will tell you what's wrong with your image.
Oh my gosh. Wow.
What's wrong with your image? I mean, you should be looking in the mirror every morning, right? So.
We're just about running out of time. Ben, I think you had something you wanted to share with us on your screen. Did you want to show that?
Yeah, I do. We're slated for the NAB coming up in a few weeks, and we've got a new product out. And if you can, I'll try to not make it too salesy, but this is a new product for Inovonics, and it's an HD modulation monitor. And we've got two different versions. We've got a full version where it's got all the big LCD on the front and lots of eye candy. And then we have a 1U version where it just has the main data through the web interface. But as far as metering and everything like that, you can look at the FM metering. You can see total modulation. And this is actually reading real modulation off the air in real time. You can look at HD metering, which is going to give you, these guys have 3 different HDs. So you can see that the top one, the meter is HD1 audio is right in the same level as the FM. HD2 is running consistently and in peak level there, which is important because if you're tuning from an HD1 to HD2, you don't want the level to drop way down or
right.
Increase. Their HD3, it looks like is running around 4 or 5 dB lower than their HD1 and HD2. So you can see that information. As far as spectrum plots, it has a complete spectrum analyzer built in.
Oh, wow.
So this is picking up off air, and so you are going to get spikes and things like that. If you plug this right into your transmitter, then it'll be golden as far as your levels and everything.
That hump on the right, that's another radio station over there, isn't it?
It is. It's a translator that's 200 kilohertz away.
Okay.
And it kind of clobbers their upper HD sideband.
Yeah.
But you can see the upper sideband measurements, the lower sideband measurements, and of course the total injection level. You can turn your masks on and off, set those. You can set the response and the peak and average and everything. So it's got a lot of information in it. The other thing that it has that'll be very interesting to people is that you can show your FM and HD alignment. So Up at the top, you have a little green squiggly line, and that shows you your confidence that the measurement that it's taking is really an accurate measurement. And then over on the right, the scale is 0 to -1, -2 right now, to show you that it's right in sync. It's going between 0 and -1 samples, so it's only off one sample. That's not too bad. And then, of course, the listener experience. It does what we're looking at, similar to the other stations. So you can see the logos, you can see if there's issues with all that. So I don't want to be too promoting on that, but come see it at the NAB and get a closer look. We'll have a couple on display there, and it should be a great box. It's something new for us.
We're actually, I know we're almost out of time. You've got to go soon. We're actually going to get salesy for 2 minutes here because you're a sponsor of the show anyway. So we're going to check out the Aaron 655. We're talking to Ben Barber with Inovonics. We'll be right back with our tip of the week. Ben's got a tip for us. Hang on. We'll be right back.
The Aaron 655 is the latest addition to the Inovonics family of rebroadcast receivers, designed specifically for FM broadcast translators, also referred to as relay transmitters. The Aaron 655 is unique as an uncompromising DSP-based HD radio and FM receiver combined with a powerful 3-band audio processor and dynamic RDS encoder. IP connectivity adds streaming capabilities, and a web browser interface gives you total remote control of the unit from any PC or mobile device. The Aaron 655 gives you maximum flexibility for program sources. Select program audio from analog FM, digital channels HD1 through 8, streaming sources, and analog or AES digital line inputs, all with assignable failover audio backup. The internal RDS encoder allows you to customize your RDS messaging. You can use incoming off-air RDS data, convert HD radio pad data to RDS, convert streamed metadata to RDS, or receive IP telnet data. Comprehensive audio processing includes gated and windowed AGC, a unique syllabic leveler, 3 bands of compression, and both wideband and independent HF limiting. Easy setup is achieved by using 10 factory presets and 10 customizable presets. The processor also supports day parting, allowing automatic preset changes to follow different programming formats throughout your broadcast day. The front panel has an OLED display and jog wheel with intuitive menus for easy setup, advanced control, and editing for all operating parameters. The Aaron 655 dynamic web interface gives you total remote control of the unit from any PC or mobile device. A comprehensive set of menus includes a quick overview of now playing info, input-output control, processor options, RDS encoder, alarms and notifications, SNMP settings, and much more. You can also listen to the live audio broadcast streamed through the web interface.
That is the Aaron 655 from Inovonics, and we're back for just a minute with Ben Barber, the CEO at Inovonics. I know the whole show's kind of seemed like an ad, but there's technology here that engineers need to know about, and I've learned some things today too, even though I was an early customer of Inovonics way back in 1981 or so. Ben, do you have a tip for us before we have to go?
The tip I want to leave you with is that, especially for remote monitoring, is that unless you have some piece of gear there, whether it's a full-on remote control monitoring system where you're monitoring your temperature and AC and generator reliability and battery or transmitter temperature, unless you have something there to monitor, you really don't know what goes on, and you need to know what goes on. As an engineer, you need to be there, be able to access that remote broadcast site. And so if you don't have anything, then get something.
That is so true. And I'll tell you, these days, at my own stations, we seem to have trouble getting our own employees to monitor our, well, frankly, many radio stations. So we had an AM station that was off the air for 3 days, and we didn't know it. Yeah.
Okay.
Yeah,
Inomini 637, Kurt.
Yeah.
Okay, there you go.
That's why I went and looked at that and said, really, they do this with AM as well? And I love the power level over time. You can see when you change patterns or power levels.
Right. Yeah.
Amazing.
There
cool.
you go.
Ben, thank you so much for your time and the innovations coming out. You got something cool at NAB. I know a lot of people won't be there, but if you will be there, see the Inovonics booth at NAB, right?
All right. Yes. Thanks so much, Kurt. Great talking to you.
Thank you. All right. It's This Week in Radio Tech. Ben Barber's been our guest, and we've got another great show coming up next week. So we'll see you next week on This Week in Radio Tech. Bye-bye.